Okay, in this video, we're going to discuss arithmetic sequences. In real life, you'll come across all kinds of patterns in business and engineering. An arithmetic sequence is like a mathematical pattern, one of the most basic, but still it's very important because if you understand arithmetic sequences, then you understand how to work with sequences, how to identify them, analyze them, look for characteristics. There are other types of patterns or sequences we're going to discuss in other videos, like a geometric sequence. There's telescoping series. There's different kinds of patterns, Fibonacci sequence. So learning about an arithmetic sequence is foundational for working with sequences in general, more complex sequences. So all an arithmetic sequence is you have the first term, and then each term you add a common difference, D. Right, so let's say we're starting at 2 and our common difference is 3. Then we would say, okay, 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11, etc. That's it. Very simple. So as far as writing an a sub n, if you think about it, this would probably be pretty easy to create a recursive formula. Recursive formula might be the simplest way of representing this. Why is that? Because think about it. Any term, the nth term of an arithmetic sequence is the previous term, the term previous to a sub n, plus the common difference, right? That's what you're doing. Each time you're just adding d. But if we want to write a sub n in just a general form, how would we do it? Okay, well, we can see what the pattern is here. Just your starting term plus, and if we're starting at n is equal to 1, then we would have to do n minus 1 times d, because you'd start off at n is equal to 1, so this would go to 0, and you start off at a sub 1. Then at n is equal to 2, you'd have 2 minus 1, 1 times d, so a sub 1 plus d, then a sub 3 would be a sub 1 plus 2d, see? And so this is a simple sequence. Because it's so simple and basic, we can find a formula for the s sub n. We talked about that in the introduction to sequences and series, how finding an s sub n for a sequence is usually not that easy to do. If you can, you might have to use like mathematical induction, but for simple sequences, simpler sequences like this, we can just use clever methods to find s sub n. So just a reminder, s sub n is like, so the sum of s sub 1, the sum of just the first term is 2. S sub 2, the sum of the first two terms is 7. S sub 3, 8 plus 5 is 13 plus 2 is 15. S sub 4, 15 plus 11 is 26. Right? This is a new sequence that's called s sub n. This is a sub n, and this s sub n is connected to this a sub n. Okay, so how can we find the s sub n of an arithmetic sequence? So again, many s sub n's you can use mathematical induction, which we'll talk about in another video. But here we can just use a clever trick. What you do is you say, okay, let's first write s sub n in ascending order. So, meaning just like this here. So, a sub 1 plus a sub 1 plus d plus a sub 1 plus 2d plus a sub n, right? It ends at 8 sub n. Okay, now we can rewrite s sub n in descending order. So a sub n, and then what would the next term be in descending order? You just have a sub n minus d, and then a sub n minus 2d, and it ends with a sub 1. Okay? You can see these are the same thing. All right, so now let's add these two equations. So s sub n plus s sub n is 2 s sub n. So here, a sub 1 plus n plus a sub n. And then you add these two, and the d's plus d minus d is 0. So you get what? You get another a sub 1 plus a sub n. Plus, again, 2d minus 2d is 0, so another a sub 1 plus a sub n. And then at the end, another. Okay, so how many of these a sub 1 plus a sub n's do we have? Well, we start at 1, and we go all the way to n. This is just n, right? So now just divide by 2 to solve for the a sub n, or to solve for the s sub n. So there you go. That's f sub n. If you wanted to find the partial sum, so remember, when we talk about a series, that's the infinite sum of a sequence. But a partial sum is you're taking a series and you're limiting it to a finite number of terms. So if I said, give me s of 100 of a certain arithmetic sequence, I could find the partial sum of the first 100 terms. So I mean, you could even take this further. So this a sub n, we know it's for in this general a sub n. This is a general formula for any arithmetic sequence. This is a general formula for a sub n for any arithmetic sequence. So we could say, so s sub n is equal to n over 2 a sub 1 plus, now a sub n is a sub 1 plus n minus 1 times d to a sub 1 plus, right? And so if you have now, so if you have a arithmetic sequence, you're going to know the first term, right? You're going to know the common difference. So now, so this is, you know, a little simpler to understand. You don't have to separately solve for the a sub n here, you see. If you want, you can simplify this. You can distribute this n over 2 and make this look even cleaner. Right, so let's see. So let's do that. So s sub n over 2 plus dn minus d. So n a1 plus 1/2 dn squared minus 1/2 dn. And maybe you can factor that, but this might be a little too messy. So maybe this is the cleanest form. Just leave it like that. But you get the idea. Okay, what else? What is the limit of an arithmetic sequence? Or what about what is the limit of the s sub n of an arithmetic sequence? Well, if you think back to the introduction to sequences in series, to get the terminology right, the limit of an s sub n is just the limit of an s sub n of an arithmetic sequence would just be the series of an arithmetic sequence. What is an arithmetic series equal to? The sum of an arithmetic sequence, right? So the sum from n is equal to, let's say it starts at 1. It doesn't have to start at 1. to infinity of a sub n in this situation is equal to the limit as n approaches infinity of s sub n, right? Well, you can imagine just intuitively this limit's going to go to infinity or negative infinity. If your d is positive, the limit's going to go to infinity. If your d is negative, the limit's going to go to negative infinity for both the s sub n and the h sub n. Because you're adding, like for a positive d, you're continuing to add, like you're pretty much getting like at infinity, you're saying a1 plus infinity times the common difference. So the common difference is positive. That's just going to go to infinity. That doesn't converge to anything. If the d is negative, that's going to go to negative infinity. And if the sequence is going to infinity, then summing all the terms of the sequence will also go to infinity, right? You can think about that intuitively. Okay, so that's arithmetic sequences.